welcome every one of you to today's webinar regarding the topic for today is defeating the complexity with use case optimized Kubernetes platforms. My name is Sergey. I'm a product manager in Mirantis. I'm taking care of the MKE product line portfolio and everything related to enterprise-grade Kubernetes solutions in our company. So today I'm going to be talking quite a bit about, the platform engineering side of things. How do we simplify the complexity? How do we embrace the multi-cluster thinking and propel ourselves for the success in over-complex environments of Kubernetes? So without further ado, let's start off with laying some context and some basics. So why is the Kubernetes platform, complex? What makes it complex? What are the typical, considerations that, our customers or users overall have when they deploy or even consider Kubernetes as a solution for their container platforms? So first, we typically slide into, an idea that we will have this, one super big kind of beefed up and very kind of shared cluster that we will then provide to diverse, teams, and rely on the fact that Kubernetes will handle that sharing or that isolation by itself. Bad news, it won't. So the trend that we see typically with customers who embrace, a single cluster approach is that you really need to be careful in your planning capabilities and how do you explicitly solve your user kind of permissions, the whole user management scenario. So how do you properly set up your roles, your rule bindings, rules overall? So the whole RBAC side of things, which is by itself an area that we can spend a whole webinar referring to, but then by itself, the Kubernetes is only providing a very Kubernetes native solution, which is namespaces. And to be honest, the level of isolation between namespaces is something that we can debate, but obviously it's not like the top level isolation. Even if you properly implement RBAC, there are some caveats and some lessons that we as a player in the Kubernetes enterprise platform space, we've kind of acknowledged that when we are talking to customers about the proper isolation, either for workloads level or for teams level, we try to implement this cautious approach. It doesn't mean that you cannot do that. It purely means that there are certain better ways how to avoid overcomplicating and overblowing clusters and their workloads. So now I mentioned that you work with a certain set of workloads that run in your environment on a single platform, and then you want to introduce more complexity. And by more complexity, we can just simply imagine a policy engine of a sort, like Kubernetes or OPA, Gatekeeper, whatever you want. And we set up guardrails, we set up baseline policies, we set up network isolation or network segmentation even. And then you overlay that with existing but not maybe well done RBAC, and suddenly you really need to go and deep dive into the way how your end mission controllers and policies that you've imposed on them affect your users in their certain roles. So if a role A, like a developer or a DevOps architect, needs an access to be able to do a task XYZ on a certain host in your environment, which has a very strict policy. So how do you enable that use case? So do you go and redo the policy, or do you go and redo the role and role binding and everything associated with that? So these are the trade-offs and complexities that I'm talking about, right? So it's challenge, and we think that a lot of the even super skilled administrators and platform engineers can struggle with certain scenarios as your platform grows, as your workloads grow. And ultimately, if you adopt, things like a proper GitOps or a proper CI/CD techniques that enable you to scale and version your workloads properly, then how does that pair with a certain restrictions and role bindings that you have on a cluster level? So with that in mind, One of the very kind of easy to consume style of thinking is the multicluster style of thinking. So what you do is you embrace this kind of mentality where you try to understand how to declaratively do a cluster spec, right? So you imagine that you have a workload of certain kinds, of certain type, and then you say, well, for that type of workload, my cluster should be very tightly secure, or my cluster should have, a zero permission policy, and it should be really tight. And I only want, users with the super admin or admin privileges to be even able to see what's happening there. And then you kind of move an extra step or a next step from that, and you try to understand what's the kind of lifecycle aspects or lifecycle dependencies of that type of approach are. So if you have one big cluster, then obviously if you're scheduling for an update or just a patch or a fix of something, then you typically do plan ahead well your maintenance windows, you prepare your workloads, you do all the backups, and at the same time you try to understand how to properly manage what type of workload in which namespace is being resetted when, right? So in a rolling update, typically you do like one by one host, evacuation, and then you basically cordon drain nodes and you restart and you have a newer version available, and then basically your workloads are put in back. Since they're ephemeral, so there's no problem with that. However, the problem occurs when you have an extra layer of complexity, like already mentioned, policy engines, right? So you still can have a situation where in a certain set of nodes in your cluster, you will have temporarily, although workloads that are different in sensitivity towards, from your compliance perspective. And embracing this multi-cluster thinking actually helps you understand that several clusters, or this approach when you make a workload cluster, makes suddenly a lot of sense. And typically, even if it's not doable by default on a single cluster level, the thinking methodology and way how you apply the thinking is very viable. So where we're going with this and how we in Mirantis try to position some of the products that we actually sell, but in general, also as a consultancy, we try to bring this, or embrace this logic to, existing customers and their critical workloads. So what we're saying is that if you really think about workloads and their dependencies across the stack, so how do they pair with, your Kubernetes native services, like, the LMA stack, like logging, monitoring, and alerting, like different other services that see deeply and analyze the underpinnings of those workloads. So they understand, for example, the cost methodology as an example, or something, or some other aspects of that workloads being deployed in the platform. But also, already mentioned compliance policies, user management, stuff like that, guardrails. We typically recommend that, hey, this stack that you're now working with is much more agile than just having a really big, overblown cluster. And maybe it makes sense to, split and have a very, reasonable way of administering workloads and being, centered around that workload as a first-class citizen, rather than positioning your container engine cluster as a first-class citizen. So this is a change of the paradigm, right? So workloads are obviously the kings of the container platform. And now comes an extra step, an extra way how to understand and how to basically scale and repeat what we just talked about. And that's going away from bare bone, anonymous, but very overblown clusters to, use case optimized clusters, where you, at the beginning, when you build the cluster, you define what that cluster should be built around, right? So there are many examples, but for us here, we are, as you may know, Mirantis is heavily involved in several open source projects. So for us, one very specific example is the K8s Platform, which is an open source CNCF sandbox project that we kind of sponsor. And K0s has a huge advantage that it is packaged and delivered as a binary. So you don't have a really big dependency across the board. So you basically deploy a single binary that inside builds a whole container platform or a whole Kubernetes distribution, if you will. So if we take that as an example, so by itself, K0s is just a container platform or just a version or a distribution of Kubernetes. But then if you take K0s and you apply a certain set of logic that will tell the K0s, hey, if you are to boot, then please add that networking component, this storage component, that admission controller, and that user management solution, either DAX or Keycloak or whatever you name it, and you create something like use case optimized blueprint to solve your needs, and always have in mind that, hey, my workloads are kings and I want to deliver, the best residency for those first-class citizens, then suddenly it all makes sense. And due to the fact that Kubernetes platforms and the K0s, I already mentioned, is heavily reduced in size, it's very nimble. So it's a couple of megabytes, and it's very kind of transferable. So you're no longer bound to having the big, bare metal boxes or overblown virtual machines. And now with this nimble Kubernetes distributions, you can actually, deploy at edge locations or even on things like Raspberry Pis. Don't get me wrong. I'm not recommending you to build enterprise-grade solutions on top of Raspberry Pis. Where I'm going with this point is that the ability and the way how you consume Kubernetes is changing in time, and we are developing, we're moving ahead. And the ability to have several clusters in your environment serving per workload, use case optimized container platform is not a luxury, it's more a necessity. And if you consider everything that I've been just talking about regarding this multi-cluster thinking methodology and the set of artifacts and set of layers that needs to serve the purpose of that specific workload, we suddenly get into an understanding that the multi-cluster and specifically the multi-cluster use case optimized approach is just way more efficient. It's basically the state of affairs that we see now in a lot of our customers and a lot of those really hardcore production environments to appear more and more. Even seemingly, it may seem like a bigger burden on top of platform engineering teams, but the reality is way simpler. A lot of the platform engineers are embracing CI/CD toolings, GitOps toolings, and for them, every cluster with a cluster spec and those different templating mechanisms that you have either through cluster API or now with K0s, there's also a Cosmotron feature that you can utilize for the same purpose. And then suddenly the level of automation, the level of blueprinting those platforms is reasonably higher. So if there is a concern or a fear that this is something that is super complex, believe me, and we are gladly, I'll follow up on this with you or for your specific needs and demonstrate that this is actually the other way around. So if you are serious about, maintaining well and healthy production workloads, then actually this multi-cluster use case optimized platform makes a lot of sense. Now, the automation, right? So the main driver behind the use case optimized platform is about making sure that it's not prone to human error. That's A. B, it's always a declarative approach. So you as a platform engineer, you just declare end state, and then certain toolings, operators, or just Argos CD and other tools, they make sure that this declarative approach is set and that the desired end state of the cluster is achieved. At the same time, whenever you define your lifecycle management approach, so if you say that, hey, I want to be always at the bleeding edge, which most probably you won't, because in enterprise grade scenarios, you typically want to have a very well-established, stable platform, and you need to, make sure that you're compliant and you've been certified properly, and you stay on a very well stable, secure version for some substantial amount of time. In any case, you still do patches, right? So from that perspective, embracing this automation that I've just talked about via either fully open source tools like I listed here, or via commercial grade tools is actually a really good way to go forward, because then you basically compile a list of primitives in those pipelines, and you are always setting up declaratively the steps that needs to be taken to achieve the desired end state from both, the infrastructure perspective. So if you want to add a disk, add a node, or you want to apply a patch that has a CVE fix, or if you want just to update a version of a certain component that has some issues, or your business drivers are demanding a newer version of a toolkit. So all of these drivers, they actually segue you towards adopting some types of automation or GitOps or CI/CD as you wish. And that works pretty well, as just mentioned, with the use case driven optimized platforms. I like the sort of blueprinted platforms, right? So you have a blueprint, what it constitutes of, the versions, your cluster is serving a first-class citizen of a certain workload, and then everything else is dictated by that. And you just adapt, right? So you know that you need a patch somewhere, and you just apply it there where it's only needed for that workload to be alive and running successfully. With that said, there are a couple of strategies for very long-term utilization of, the use case optimized container platforms. So first, as I just mentioned, you want to update. So even though certain maintenance in general and, patching specifically brings a certain level of stress for both platform engineering teams, for SREs, and across the organization, that's just how things are. So things just can crash and platforms may occur, and there are certain strategies to negate that, absolutely, and already in place by modern IT enterprises. But in general, reiterating what I just said, if you have a prescribed use case optimized platform that you've defined well on some blueprint level or some CI level, then the predictability is quite substantial, in a sense that you can always try and run the same set of steps on just a different host, maybe somewhere in staging or dev environment or test environment, and see what's happening. And then only after the testing, which is of course done automatically in your CI, only then you apply your updates and patches to your production environment. Of course, monitoring, that's very important, and you always want to have, if you can, a proactive approach to monitoring in a way that you feed your logs and metrics to either third-party software, something like Datadog or something else, and you try to see the trends and the patterns there, and that helps you, be prepared for any potential issues or risks. And of course, the beauty of the CI/CD toolkits today is that you can automatically incorporate that feedback from proactively monitoring into your optimization loops. So let's say you've had a patch in Q1, and then you're looking to have a patch in Q3, but something from that patch in Q1 went wrong, and you want to avoid the same set of nuances or complications going into the future. So one of the very sophisticated or well-desired ways to solve that is to feed, your log metrics into a third-party system, ask for an analytics, employ that, monitoring results into your CI, and try to implement a better, more efficient way to do patching. And again, since your cluster definition is already use case optimized and you are working with a single workload, it makes things a lot easier, because troubleshooting a multi-workload, multi-namespace, multi-100 users cluster is much more complicated and not so predictable as the use case optimized platform. I've been talking a lot about, the open source project. I've mentioned the K8s as the platform that Mirantis sponsor, and I mentioned Cosmotron. that is a cluster API and an overlay solution for K0s. But in general, if you look into the field of open source toolkits that are currently present in the market or in the CNCF landscape, you will see that there's like really big diversity of tools that can help you achieve similar results, right? So as a highlight, so we all know kubeDM, Helm, right? So these are some default options. And of course, you can still go and deploy, things via manifests. Nobody will stop you from doing so. But the automatization that Helm brings into the table is a really great option. And we at Mirantis love Helm. We currently have multiple products that have Helm built in them, like Mirantis container engine, Kubernetes engine, and others that are on the table. And we actually are very active in the open source world of both CNCF landscapes, as I mentioned with K0s, but also contributing to many other systems. Like we've recently published a blueprint operator that helps us build those mentioned blueprints. And I'm definitely open to have any reasonable discussion around that if you're interested to see where we can help you out with your challenges. But in general, even the very standard Prometheus or Grafana stack that helps you monitor and proactively analyze your environment. Then you have tools like Argo CD that are perfect for implementing those automation pipelines. Helm as an automation that is quite desirable. And others, they help you build this whole stack around your use case optimized clusters. So it doesn't mean that you have to lock yourself into a black box or a proprietary toolkit. It's about embracing this multi-cluster thinking and understanding that there are tools both in commercial grade offerings like Mirantis, but as well as pure open source project that will help navigate you through that challenge. And some takeaways that I would really like my audience here to take away from today's relatively short webinar is that we in Mirantis think that multi-cluster thinking is about primarily reducing complexity. Even though on the first hand it seems like having more cluster than one is more complex, but the reality and the real use cases that we see at our customers provides the insight that it's actually the other way around. So if you properly set up your use case optimization and bring and build blueprints for those use case optimized clusters, then that multi-cluster thinking actually starts to make a lot of sense. And as I mentioned, also what plays into the cards of that claim that I'm putting here is that the Kubernetes distributions themselves are getting so nimble, so lightweight that you can actually dedicate much less resources per cluster than it's used to be. And to be honest, just purely the etcd scale is one very big concern, that if you are running hundreds of nodes with thousands of pods there, that is something you really need to consider well ahead if you're going into that scenario. While with nimble clusters, it doesn't present that kind of a challenge. Second huge benefit is the declarability of the stack. So you are very much in control what is going on in that one specific cluster. So you declare automation, you declare policies, you declare your toolkit and how the workload is being placed on top of those multi-cluster scenarios. And last but not least, you don't have to consider a challenge of being locked away by a specific vendor here, because there are plenty of toolings in the open source. Some of them are backed by Mirantis, others are not. There are, of course, commercial grade products that will always help you out, and we will gladly talk about that with you about your specific scenario. But otherwise, they are definitely available and they're super cost effective. I think that is all from what I wanted to talk about today. Feel free to reach out to me directly or to Mirantis folks, either on social platforms like LinkedIn or directly via email or chat. We are definitely here to help you out, to discuss your concerns and to share our thoughts on how open source technologies and commercial grade solutions converge. Hopefully this was informative for you, and that's been my greatest pleasure. Thank you.